One of the reasons we talk about reliability after talking about correlation is because determining reliability depends on correlation. Essentially what you're doing is that you're assessing the reliability of a measure by looking to see how closely two different measurements accord. So in terms of the forms of reliability, the 3 forms of reliability we discussed in the last video, a reliable measure is one in which either the scores of the ratings of observers correlate well with each other, or the scores of multiple items, or like the different types of food, measure the same across each other, or very similar to each other, or the observations made across given times are going to correlate well with each other. And those are reliable observations in any one of those conditions. So this week, actually, or the very beginning of next week, we've got our exam number 2. And so let's talk a little bit about this in terms of exams or tests. So if you had a negative correlation, so high scores, or as scores go up on the first test, then your scores on the second test go down. So the higher the score on the first test, the lower your score on the second test. That would be a negative correlation. Is this a good thing? Would you want to see a negative correlation in terms of reliability? You know, if you maintain your study habits and you continue to do things in a correct way, then you really wouldn't expect, like, okay, I studied on the first test and I studied on the second test. I got a high score on the first test. You expect to get a high score on the next test. And so negative correlations, it's just like with the food thing. If you had a rater that scored like high on one, and then the next thing they looked at scored low on that, that's not something you would see with reliability. What you want to see with reliability, in order for something to be reliable, are positive correlations. High scores on the first test associated with high scores on the second test. Getting high scores in terms of, oh, they're really good at the way they do meat, like in terms of a restaurant, or the way that they do desserts, or the way that they do appetizers. You want to see those high scores across multiple observations. And so essentially what you're looking for with reliability, the higher the reliability, the more reliable your measure is, the closer it actually gets to 1. You're looking for high positive correlations between things. So remember when we talked a little bit about correlations, how when we're looking at social science measures, because humans are so variable, we tend not to see very, very high correlations between things. We're pretty happy with a 0.3 or a 0.4. Even in the last article that you actually read, you know, there were correlations at 0.20, which is pretty small, but those were highly significant correlations. That's not necessarily the case with reliability. Ideally, when you're looking at the reliability of a measure of some sort, you're looking for, like, you'd love to have a perfect correlation, but you're really looking for high ones, and you can expect maybe not a perfect correlation, but the closer it gets to 1, the better it is. The lower the reliability goes down, the lower the correlation is, the worse the reliability. So you're looking, you know, in measures, you start being suspicious about the reliability of a measure if it's at like 0.60. You want it to be extremely reliable, that the more you use that instrument, every single time you measure it, you use it to measure something, you should be seeing very, very high scores across observers, or across times, or across the different questions in a measurement instrument. When the reliability goes down, like I said, then you have some real concerns about measurement error, because that's what would be causing that. So inter-rater reliability refers to the degree in which different judges independently agree on an observation or judgment. We see this all the time. We do this in research where, like even in my own research, we have poems that we actually, you know, sort of rate in terms of various things. And I always have at least 2 people go through the same sort of thing. It's really easy sort of stuff. And then they rate it. And we look to see how correlated the ratings are and how close, like in terms of them coding things, they are. And actually, I expect perfect coding. So if there's a disagreement between the two, somebody made a mistake, and then we have to go back and we sort of check to see what's the case. But, you know, like I said, in competitions and things like that, you actually are looking at inter-rater reliability. And so what you're interested in is the degree to which multiple judges agree on the observation. So in the Olympics is a good example of that. Somebody performs some sort of an act, you know, gymnastics or something like that, and then they get a rating. Now, if you're looking at these scores right here, these are pretty reliable ratings. They're all very, very similar to each other. Now, if you see something like this, that's not so reliable. Well, 2 of the people are pretty reliable in terms of inter-rater reliability, but then we have this sort of outlier here, which is problematic. This is used, like I said, in many real-world situations. This is what you'd like to see between your raters. This is not what you want to see. And basically, what you need to do in order to get higher inter-rater reliability is actually to make sure that your judges are trained in how to code the particular behaviors that they're actually looking at and test them and practice them. So it's like you don't give them the actual data, like the data they're going to be coding to practice on. You give them other examples. So maybe in terms of the Olympic judges, you have various performances from past Olympics, and then you say this would count for this, and this would count for this, and this is how you rate these sorts of things until they're all trained. And so you could, like, all of them can be training together and practicing on the videos together and discussing it. But when it's time for them to do the actual coding itself, of the actual data, each of them have to make those assessments independently so that one doesn't unduly influence another. And that's the point when they make these independent observations that you can assess the inter-rater reliability of those options or those observations. So to do this, what you need to do is you have to train the judges on the coding scheme. They're free to, like I said before, they're free to discuss the rating with other judges, but only during their training. When they're actually judging the behavior themselves, they have to do it independently, individually. They measure it and rate the behavior individually, and then afterwards you can assess the inter-rater reliability. They only do it together when they're actually being trained. So when do you do something like this? Well, what you need to do here is basically you want to do this inter-rater reliability when the behavior cannot be assessed by simple physical actions. It's like, did they jump 5 feet? And we have this measurement here in terms of 5 feet. You can see the measure there. Or, they lift this much weight. That doesn't take an independent, like multiple judges to be able to determine it. It does, like in Olympics, there's nuances to what people are actually doing and different ways of interpreting it. So you need multiple judges. It's a little bit more subjective. Maybe that's one of the ways that you can actually engage in it. It's used when a behavior cannot be assessed by simple physical actions, or you don't have some sort of a measuring instrument like like a reaction time detector to see how quickly people sort of responded to something. When it's more subjective or more qualitative, then you should actually have more than one rater, and then you need to look at the inter-rater reliability between observations.